Hello students, welcome to Sarasa classes, and we are continuing with the solutions of PUBDET 2019 question paper. So we are going to deal with the question number 14 over here. So for 14 the question is 262 milligrams of xenon gas reacts completely with 152 milligram of chlorine gas to form a mixture of XeF2 and XeF6 in the mole ratio of Ms to N. Atomic weights of xenon 131 and fluorine is given 19. The ratio of Ms to N is, we have to find out. So for this reaction, xenon is reacting with say N moles of F2 and it is forming XeF2 okay, let's call this as X and XeF6. So let's first calculate the number of moles of xenon gas, and for that we will use the given weight, which is 262 milligram divided by 131 gram per mole. That means it will be equal to 2 millimole. Okay, now for gram molecular weight of the diatomic F2 gas, it will be obviously 18, sorry, not 18, but 19 plus 19, that is going to be 38 gram per mole. So if we calculate the number of moles of the F2 gas, that is the given weight, which is 152 milligram divided by 38 gram per mole, and we can say this is going to be 4 millimoles. Now if we say for the solution, we are saying that let the number of moles of XeF2, all right, XeF2 be A, and number of moles of XeF6 be B. So now applying POAC, okay, we can say A into 1 plus B into 1 is equal to 2. That will give us equation A plus B equal to 2. So this is equation 1. And 2A plus 6B is going to be 8. So that is our equation 2. Alright. Now if we solve the equations, of 1 and 2, okay, what we get is 2A can be written as B minus 2 plus, sorry, 2 minus b, 6b equal to 8, or we can say 4 minus 2b plus 6b equal to 8. If we do the math, we will find therefore b is equal to 1. So number of moles of XeF6 is 1, and if we use the equation 1 out here, then we get the value of 1, A to be as 1. So over here, moles of XeF2 is 1, moles of XeF4 is 1. So here obviously we will say our answer is, that is the M is to N ratio is 1 is to 1. Okay. Now for the next question, which is question number 15, which of the following is correct when a solid NH4Cl decomposes on heating to give NH3 and HCl gas? So we have NH4Cl solid, you're heating it, so this is the delta H for the reaction of decomposition. It is giving this to be as the gas, and obviously HCl is also the gas. Now if we find out the delta N, which is nothing but summation of number of moles of gaseous products minus summation of number of moles of gaseous reactants. So we can see here it is 2 minus 0, so it is going to be 2. In other words, we can say entropy, which is delta S, increases on going to product side. That is, delta S out here is positive. Okay. Now since in this reaction energy is absorbed, okay, so here energy is absorbed, which means it is a endothermic reaction. So obviously we will call the delta H over here to be as positive. So delta S is positive, delta H is positive, so obviously here our answer is going to be again A. Okay. I hope that explains how to solve these questions number 14 and 15. Thanks for listening. Keep visiting Saraswat classes for the rest of the solutions. Have a great day.